Okay, great. Well, welcome everybody. My name is Fabio, and I am an iOS developer at Touch Wonders, a mobile agency based in the Netherlands. Today, I would like to talk about frameworks, what they are, why I found them really useful, and how we can create one. I'm sure that many of you heard this sentence before, maybe from a family member, a friend, or a colleague, or just yourself. And as a developer, you take this idea made of functional and non-functional requirements, and you start to lay out the basic of your application infrastructure. What kind of capabilities does it need, or on which device the app will running on? And as apps deliver functionality, content, and great user experience for the Apple dense ecosystem, frameworks became the solid building blocks for an application architecture that is reusable, robust, and scalable. And if you think about the great app idea, I'm sure that behind that you're going to find great framework idea at its foundation. Frameworks are a great way to share code, but not only. You can also put everything that you think is worth to be shared in your project. You can see that in practice as a special box, and everything you put inside of it is able to be shared between all your targets. You can put in there a Swift file, Objective-C file, assets catalog, as well as localizable strings. Take a look at your code. Look out for patterns. If a code is repeated more than once, then it might belong to a framework. Take that code and put in a framework. Look up your image asset catalog. If an image is reused in your application or in its extension, do not copy the image between all different targets, but take that image and put in a framework, and use the framework as a final sharing point for everything that you wanted to reuse. But frameworks are also a great way to actually lay out, to sketch your application infrastructure. You can draw them as a simple box that you can reuse or link each other. And this is quite a requirement if you think that nowadays this is what we have. We have to make applications that can run on multiple devices that are facing multiple platforms, capabilities, and limitations. This sketch wants to represent something that I'm sure you're really familiar with. Request a remote resource that returns as a JSON blob, and then you parse as an application's model object. Example in case, a simple login feature. The user taps login, and the login request goes out, and it comes back as a JSON. Then you parse the JSON into something we could call a user model object. Great. Then you continue your development, and you want to make an Apple Watch app. Great. So you make sure that the login feature is implemented also for your Apple Watch app, and you're ready to go. But it's not enough. You want to bring your app to the content of your app to the big screen. Therefore, you continue. You want to make the Apple TV app. Nothing you can do without a login, so you start with that. And you make sure the login feature is also implemented. But before you continue your development, something happened. The login API requirements changed. What happened is that all the clients that are using the login API are now requiring you to implement or have 2.0 authentication. And this change must be propagated in 3 different implementations that are running in different platforms, and every platform, again, has its own limitations and capabilities. This is far from great. Even if it's not impossible to update your code to comply to the new standards, what happens if one day, as Natasha has told us before, we want to implement a new application extension? Then we're going to have our code again. Another implementation will be like hell to maintain. This is how your application structure will look like if you would have used a framework. As you can see, a framework can actually expose to the outside world a simple API like the login, while internally is implementing all the requirements to make the login feature happening. And the next time that something on the login will change, we can better take action by improving the internal implementation of the framework without ideally changing what we are exposing to all the clients of the framework. And it's also worth to mention that the code that goes in a framework can be easily tested in a way that most of the time you do not need to launch your app to actually test that code. And that can save a lot of time. So from the previous login example, we have seen that when we want to support different platforms, we are creating different applications. And we have seen that it's not actually a bad idea to reuse some components. Our login framework, for instance, can be named the networking framework, which is responsible to make all the communication between the different version of your application and the remote resource. Developing a framework empowers you to share your code between different targets, and this is a different ballpark than actually put your code that goes directly in your application. It also helps you to enforce 3 important software principles. Every framework should represent one idea and one abstraction only. If during development your framework is starting to represent more, then maybe it's the right time to create a new framework. Although, take into account that the trade-off with strict separation of concerns policy could cause your app to load so many frameworks during launch that the application launch time can be affected by it. So there are many ways you can prove this, but definitely take advantage of this environment variable that you can set in your scheme to have a statistics of how your app is performing when you're loading all these dynamic frameworks. Framework RAPI. What you expose is a really nice high-level interface to the consumer, while internally you implement all the messy details. Take as example one of the keychain wrapper that you can find on GitHub. They expose something nice like dictionary subscript to access data, while internally they have to do all the messy implementation with the low-level C API. It's great. Use access modifier to make sure that you're defining what is the boundaries between what your framework is exposing and what your framework is internally implementing. And remember, if you're marking something as open, that might introduce your framework to be a little bit fragile. Last, as a consequence of the first two, the code in a framework is easier to maintain because, of course, it's less code than a big code base of your main application. So all of this is great, but how does it work in practice? Well, like for an app idea, everything starts from Xcode. This time, we're going to create a framework instead. And before we continue, I will suggest to actually stick with the one convention that will save a lot of time later. It's a convention that's been introduced with the Swift Package Manager. It's a convention about how you structure your folder, and it's actually asking you to put all the source code in the folder that's called sources, and all the tasks code in a folder that's called tasks. Once you're done, you run your implementation, you make sure that your test coverage is good, and then you're done. You have your framework, and there you go. Well, almost. And that's because we are living in an era where your application can now run on so many different devices and platforms that your framework should try to support all of these platforms as well. So we can easily do that by keep creating frameworks that now are targeting different platforms. And if this looks scary, please don't be scary, because you have a way to specify some settings where even if you have different schema, you can still share the same implementation. Well, the problem actually is where you're going to start about testing, because the problem is that tests can only direct target a single scheme's framework. So that means that for every scheme, you have to create a test target. And most of the time what happens is that you're going to create all these frameworks that are targeting all the different platforms, but then you only write a test target for one of that platform. And finger crossed that will work for all the other platforms as well. But yeah, this is not great again. Our idea is actually to have one framework that can target different platforms, and we want to have an easy way to test all these different platforms. What I'm going to show you now is not officially documented, although it's been used by some of the open source library that you can find out there. First thing, let's clean up our project targets. As you can see now, we only have one framework and we only have one test target. Then we move over to the projects, and in the build settings tab, we're going to select the supported platforms. Here, as you can see, we have a mutable selection of all the supported platforms that we can choose. But this is not what we want still. We want to support multiple platforms at the same time. So what we have to do is to click Other, and then we can here specify all the platform that we want to support. In this case, we have added watchOS, tvOS, macOS, iOS, and related simulators. Next, we're going to set the targeted devices family, targeted device family. And this variable is a comma-separated list of numeric identifiers. It specifies the device family on which the product must be capable of running. One stays for iPhone and iPad, iPhone and iPad Touch, while two stays for iPad. As you can see, there is no mention about watch and TV. So unfortunately, the settings provided by Xcode Project Editor are not enough. How can we work around this? Well, there are many ways to do this, but I found the most efficient one by using xcconfig file. xcconfig file are file used as a supplemental file to a specific build configuration. Every build configuration can have multiple xcconfig file. And inside of xcconfig file, you can specify additional changes to the target's build settings that you have specified before in Xcode Project Editor. So how all of this works for us? Well, we create a new configuration file, and then we make sure that now the targeted device family variable is not only set to 1 and 2, but also 3 and 4 that says for watch and Apple TV. And then we make sure that we are using this configuration file by selecting the info tab in our project and then assign that to all the build configuration that are relevant to us. Next step is the last one. Actually, you have to make sure that the deployment target is set for all of the platform that you want to support, such that you make sure that your framework is only be used where you want to actually support your framework. So now everything is set in a way that you can write code that is going to run in all these platforms. And in an example of the login feature, you're going to find out that How 2.0 requires you to display a web page as a part of the authorization process. And what you're also going to find out really soon is that Watch and TV doesn't have the WebKit framework that has the WK Web View that you can use to actually display that web page. Well, fortunately, OAuth 2.0 draft has a special kind of authentication which is called device flow authentication, and it's the same authorization that is being used by YouTube TV app and the Airbnb TV app. What happens is that you display a code to the user which can enter this code on a different device where it can continue the OAuth authentication via the web browser. So how can we implement this inside our framework? Well, the thing is that we can use this if statement in which we can put when we have WebKit available, the authorized method is actually returning a completion block with the WK Web View in it. For all the other platforms where we do not have WebKit, therefore we're going to expose a different API, which is the authorized via device code. And what it returns is just a string that you can display to the user and continue the authorization flow via the OAuth 2.0 device flow. The thing is that you wrote this code, and of course, what is the first thing you do after you've wrote some implementation? You go ahead, you write some tests, right? Well, the thing is that when you run your test, you suspiciously, you're going to see the Xcode is going to yell, yeah, everything is great, everything is green. Like, wow, that's quite fast. But then, if you look close with the test navigator, you're going to find out that none of your tests actually ran. That was quite tricky, because actually the error was only logged in system logs. So, but why is this happening? Well, the thing is that the macOS platform and the iOS platform are using different test bundle layouts. Therefore, your framework is placed in different directories. To solve this issue, we're going to take advantage of the RAM path search paths, also called the RPath. And in here, you can specify a list of paths that the dynamic linking will try to use to find the framework that is required when the executable is requesting it. In this case, our executable will be the test target. So now it's great. We can write code for all our platform, and we can also test all that code. Let's play with it. And what a better way to play with it if it's not with a playground. So we start with a new playground. If we're going to import our framework in our playground, and we can actually now have a better way to understand also how are our APIs coming along. And when you're going to distribute this framework, it's also great that you can give to the user of your framework a clear practical guideline on how it's easy to actually integrate it in their projects. Finally, as Natasha told us before, application extensions are really powerful. And to make sure that your framework can also be used in application extension, you have to make sure that this variable is set to yes. This variable is about require only app extension safe API. Every time I see this, I'm so happy. Like, look at this. We have one framework, and now we can finally test this framework with all different platforms that we have. This is just great. Although, the thing is that nowadays it's getting more and more common to use external dependencies in our projects. Most of the time we use a dependency manager to achieve that. And lately there's been a lot of discussion of which one is the best dependency manager, the easiest one. My advice is that you should try to support the most used dependency manager, such that if a user of a framework wants to integrate your library, you can give to him an easy way to do that. But what dependency managers are about, really high level, is that you have a file that we can call the manifest file. Inside this file, you can put everything that's regarding the metadata of your framework, plus any dependency that your framework requires to actually be able to work. And then the dependency manager will use this manifest file to actually resolve all the dependency of your framework and give as an output an artifact. Depending on the dependency manager that you have, might be requiring additional steps to include this artifact in your project, but basically, thanks to dependency manager, you're able to integrate in external dependencies in your project. So I'm going to start with CocoaPods, which was my first one, and that this year got in version 1.0.0, and has also great socks, which I'm using right now. So with CocoaPods, you can create your manifest file by running this command. And what we'll do, we'll create something called the podspec file. In the podspec file, you can describe like the name, the version, and more important to us, you can specify all the platform that you want to support. And here, as you can see, we can do that by specifying the deployment target. Finally, you can also specify all the dependencies that are required by your framework. Once this is done, you can use the podspecs file can be used by the pod install, and we'll make sure to check out all the dependencies, resolve them, and then you're going to have an XC workspace you can use to directly use your external dependencies inside your projects. Next, Carthage. Carthage has a different approach. It builds the dependencies from the manifest file, which is called the car file, and provides you a binary framework that the developer then is responsible to integrate in its own project. As author, there isn't much you should do, since most of it is managed based on the framework's Git repository. Although, make sure to mark as shared the scheme that's relevant for your framework. Otherwise, Carthage will not be able to build it. The car file is where you describe all the dependencies, so you can use GitHub or a Git repository. And in case you want to specify dependencies that are relevant during development, but are not relevant when you're building releases, then you can put those dependencies inside the carfile.private file. And this is pretty useful, for instance, if you want to specify test dependencies. In this case, Quick is a really nice framework that dependency you can use to specify your tests. You can use to write tests in RSpec. Once your car file is ready, you can run Carthage update. And what we'll do, we'll actually check out all your dependency, and we'll then build them. The output will be the binary, the framework's binary, which you still have, although, to integrate in your project, because the approach of Carthage is not to mess up with your project file. So how we can do that? Well, again, let's go to the xcconfig file. This time, we're going to include the previous configuration file, so we make sure that our configuration still works. But additionally, we're going to specify a new setting. And that settings is used to make sure that we can have, during build time, a reference to all the frameworks that Carthage was actually building for us and to what actually was the output of Carthage. Do not forget to set the config file after you create it. Next is the Swift Package Manager. In a Swift Package Manager, it's the official dependency manager made by in Apple, and it was released with Swift 3.0. I think that Ben earlier had a great presentation, is explain how does it work. Although just to refresh your mind, you can use the package description module to specify all the information about your package you're building. You can also specify dependencies as well. Then you're going to ask to the Swift Package Manager to download all your dependencies, compile them, and link to the package module you are creating. What you're going to have in your project folder is going to be a packages folder with all the dependencies being checked out, all the sources. And then there is a .bit folder that contains all the intermediate build artifacts. If you want to continue development in Xcode, this time I will suggest to use the Generate Xcode project option, because it's the best way to actually have an Xcode project running in the best way as possible with Swift Package Manager. So now that you have the knowledge how to integrate dependencies, even if modern development is accelerated by the using of external dependencies, take into account that this is actually introducing some coordination costs. If your framework is having some dependencies, that means if you want to migrate to Swift 3, you have to make sure that all your dependencies can be actually work on Swift 3. And if, for instance, your networking library is actually highly depending on Alamofire, then you're forcing the code base to use Alamofire as well. So it's not a bad idea to have external dependencies, but please try to find out if that dependencies is really required for your framework. The user of your framework will really appreciate that. So now we have all these things running. We are supporting different platforms. We are running tests for different platforms, and we are also introducing external dependencies. We have to find a way to keep all of this working and never breaking. One of the best things to do this is to introducing continuous integration in your project. Continuous integration is a process that automates the building, the analyzing, and the testing of your code such that it can always be in a releasable state. And you can make your continuous integration workflow the best way you want by specifying different steps and by using different tools. The main goal is to improve the software quality. Thanks to continuous integration, you can catch problems as quick as they appear, because you can have an immediate feedback if something goes wrong. So fix problems as they occur and prevent smaller problems to cascading into larger ones. It helps is one of your team member or a contributor of your library wants to make a new contribution. It helps you to make good contribution, because you make sure that every time that the changes is required, all the tests are passing, all the conventions are still respected. Finally, because we are targeting multiple platforms, it's also true that running all the tests locally can be really time-consuming. If you use continuous integration, you can now move that workload on a different machine that will do all the work for you. And you can also easily specify different environment variables to have the tests running in the environment that you want. There are different tools so you can create continuous integration, although if you are authoring a GitHub framework, I will strongly suggest you to use Travis CI. The way you can easily integrate in your project is just creating a travis.yaml file in your main repo. And here you can specify what kind of machine, what is the operating system, what are the tools that you want to run. Like for instance, here we want to use as OS X image Xcode 8, And via script, you can easily define what are the steps that you want to be part of your continuous integration process. And in here, we want actually to ask the Xcode build to test all different platforms for our framework. Unfortunately, this configuration doesn't work out directly with our configuration, so we have to tweak it a little bit. And we can do that by specifying an environment variable, which then we can use to parameterize the Xcode build. That now can run to test all different platforms that we are supporting. Finally, it's another thing that I will suggest you to use is Danger. Danger is a tool that automates your team conventions to run in code review. So what does it mean is that if you have some conventions about code like code styling or something that you want to make sure is respected, like change logs or you name it, via Danger, you're able to codify all these logic requirements. Nothing speaks more than a Danger file. As you can see here, we can specify easily how we can say, for instance, if the change that is being requested has more than 500 lines, then we're gonna send a warning message that says, hey, this is a big pull request. And if actually the change is actually affecting the source code, then we're gonna raise an error. And this is how the output looks like. And this is one of the things that helps you to have a tool that can give you a great feedback about what is going wrong and what you might take into account while you're doing changing on your framework. So we are ready to ship it. We have all our tests, we have our source code, and thanks to continuous integration, we are sure that it's always in a releasable state. You start with version open 1.0, and then you start to play around, you start to define all the API, but it's really important that you're making a plan to get to version 1.0.0. Might mean nothing for you, but for most of the users, 1.0.0 means that the API is ready and it's production ready. So they will feel more confident to actually use it. Don't be afraid, get to 1.0.0, okay? So what we have learned today? Well, think to us if your code should belong to a framework or to your application. Frameworks are a great way to not only share code, but also assets or everything you think can be shared within all your targets, and enforce some good software principles. Always support as much platform as possible. Remember to always test for all that platform as well. Automate, automate, automate. Use continuous integration to make sure that all the changes that you're making will not break your code and will not introduce any regression. Finally, I think like the most important one, I learned most of what I've shown you today thanks to the open source community. And it would be great if the next time that you're going to think about your framework idea, you're going to think about to open sourcing it. Also because they will put you in a position where the code that you're writing is not tied to your main application, but for the entire world. Thank you.